Hello and welcome to a new video. This is for pre-algebra using the Math UC homeschool curriculum, and I skipped lesson 16 and 17 on the way past earlier this a couple weeks ago, and so now we're going to go back and we're going to do them at the same time. So let's see how this goes. So lesson 16 and 17 have to do with transforming between Celsius and Fahrenheit, which are two units that we use to describe temperature. There's a third unit that we can use as well that we typically don't see until high school science classes. But these two you're probably familiar with. In the United States, which is where I am located currently, we typically represent temperatures in Fahrenheit because we like to, be different, because everywhere else pretty much, I think, uses Celsius. So there are reasons to be able to switch between the two so that we all can kind of understand temperature no matter who we're talking to. So there's really just one formula that's needed to go between the two. But because we're still kind of new to equation solving, it is helpful to be able to show that formula in actually two different ways. One of the ways is where we have the Celsius degrees by itself on the left. The other way has the Fahrenheit degrees on the left. If we're trying to get Celsius, we would use the formula that has Celsius by itself. If we're trying to get Fahrenheit, we'd use the formula that has Fahrenheit by itself. It saves us from having to take, in one of these cases, from having to solve for a variable. The connection between Celsius and Fahrenheit is kind of an interesting one, and it has to do with the freezing temperature for water and the boiling temperature for water and how we can relate those. So for Celsius, because Celsius is supposed to be like the metric version of temperature, water freezes at 0 degrees and boils at 100 degrees. And I've heard fairly recently someone describe Celsius as how hot water thinks it is. So whenever it's 0, water would say, wow, that's 0% hot because it's frozen. But at 100 degrees Celsius, it would be like, wow, it's 100% hot because I'm boiling. Whereas Fahrenheit is a little bit weirder. Fahrenheit, the freezing temperature for water, is 32 degrees. And for boiling, it would be 212 degrees. And so whenever we hear temperatures like 80 degrees, we probably think oh, that's on the warm side, but still probably a nice day, depending on wind and humidity and that kind of thing. Whereas if we were at 100 degrees Fahrenheit, we would go, oh man, that's hot. If you've ever been to someplace that has 100-degree heat, you know that's uncomfortable sort of heat for we humans to be in. But the Celsius temperature that compares to 100 degrees Fahrenheit is quite a bit lower. So water would be like, man, this is no big deal. I can handle this. We're nowhere near boiling. Whereas humans would be like, oh, this is uncomfortable. I feel like I'm going a bit on a tangent here about temperature. Let's give this a try. Basically, so it's in two separate sections in the Math UC workbook. Lesson 16 has you just going from Celsius to Fahrenheit. Lesson 17 has you just going from Fahrenheit to Celsius. And then after that, there's probably review problems smattered about that would have a mixture of the two. So in any of those cases, you'd want to go back and look at these formulas or these sections and see, okay, yeah, this is how I go between them. I've got a mixture of them here for us to practice, so let's look at example 1. Change 100 degrees Celsius to degrees Fahrenheit. That means that I want to take, I want to take Celsius to Fahrenheit, so I want to use the second formula here that has F by itself. And the only thing I'm going to change is that where it says Celsius degrees, I'm going to put in 100 degrees Celsius. And then it says to times that by 9/5 and then add 32 degrees. That 9/5 that's happening, it happens because it's not 1 Fahrenheit degree and 1 Celsius degree aren't equal. Because if you think about it, the distance from 0 degrees to 100 degrees Celsius, which is freezing to boiling, that's 100. But how far apart freezing and boiling is for Fahrenheit is from 32 to 212, which is more than 100. So that's why we have this kind of weird, awkward fraction that we're having to multiply by. To do 100 times 9/5, we'd put 100 over 1. We when we multiply fractions, we do 100 times 9 and put that on top, and 1 times 5 and put that on bottom. There's also a trick you can do where you simplify before you multiply, which is personally my favorite thing about multiplying fractions. If we do that, we'd say 5 over here can go into 120 times. And it just saves us some time on multiplying and dividing, because now we see 20 times 9 is 180. And there's just ones on the bottom. 1 times 1 is 1. So this would be 180. We're going to add to that 32 degrees. So 180 plus 32 is 212, which I don't know why I keep forgetting about this as I work through the problem. I already talked about that, right? That 100 degrees Celsius is the boiling point of water, and 212 degrees Fahrenheit is the boiling point of water. So, haha, we confirmed that the formula works. That 100 degrees Celsius really is 200 degrees Fahrenheit. So, good job, us. Let's look at another example. Example 2. So we've got 50 degrees Fahrenheit to Celsius. Oh, I probably should still keep it where I can see the formula. So this time we want to use the one that has Celsius on the left, because we're trying to get to Celsius. We're going to put in 50 degrees Fahrenheit where F is, and then divide by 9 and times by 5. So we're going to do 50 degrees minus 32, which is, I'm about to do that wrong, hang on, 18 degrees. And then we're going to take that 18 degrees and divide it by 9 and then times by 5. So when you're doing PEMDAS, you don't do multiplication before division. Multiplication and division are weighted the same. So if what we have is all multiplication and division without any other operations happening other than those two, we go from left to right. So this would be 18 divided by 9, which is 2, and then we would times that by 5 and get 10. So this would be 10 degrees Celsius. So it's like winter where I am right now. It's the beginning of February. It's, around 50 degrees at some point during the day, or maybe a little bit colder than that, but 50 degrees Fahrenheit would be like having 10 degrees Celsius. So that might be an interesting thing to know. Let's look at another one. This is also Fahrenheit to Celsius. So we're going to use the same formula as on example 2, but we're going to put in 30. And this one does not work out as nicely, and I did that on purpose so that, because they're not all going to work out nicely, most likely, and I wanted to make sure that you knew kind of what to expect. So the first thing that's kind of weird that happens is that 30 minus 32 is negative 2. You've probably actually heard of places having negative temperatures before. It may not happen where you live, but if you are in certain parts of the world or the country, negative, whether you're in Celsius or Fahrenheit, negative temperatures is possible. So then it's a question of, how do I do negative 2 divided by 9? And there's two options. One is that we could divide and get a decimal. The other is that we could write this as a fraction. We could say that this is negative 2 over 9, like this. And then when we times it by 5, we'd make the 5 over 1, so that we do 2 times 5 on top, which is 10, and 9 times 1 on bottom. Nothing here simplifies, although we could change this to a mixed number, or we could go ahead and get the decimal for this as well. And I would say that personally I'm okay with, if you want to get this decimal using a calculator, that's fine, because I'm not really at the moment testing you on your ability to divide and get a decimal. I'm trying to get you to do Celsius to Fahrenheit and Fahrenheit to Celsius. So that was kind of a weird process that we had to go through, but that's kind of like example 2 is kind of our best case scenario where it all works out nicely. Example 3's are maybe not worst case scenario, but it's a not as nice problem. So let's look at example 4. So let me write this down. 25 degrees Celsius. we're gonna put right here, and then I'll scroll down, but I wanted to, oh, that's not a plus, that's a times. I want to be able to see that formula up at the top. And plus 32 degrees. So this is definitely where this is definitely a situation where it is helpful to have formulas handy, or your example problems handy, so that you know, so that you have something to look at. It may be that after doing, a few of these problems, you end up memorizing the formula, and that's great. So we would want to do 25 times 9/5. So you can do 25 times 9 and then divide it by 5, or we can see if this simplifies by 5, which it does. 5 times 9 gives us 45. So this is 45 degrees. And then we're going to add 32 degrees. So I did parentheses before I did addition there. Just by the way, this is 77 degrees, which sounds like a lovely temperature. And it would be in degrees Fahrenheit. I just realized I didn't label this one with Celsius. Like, that's typically a thing we do. Anytime we have units in a math problem, we label our answer with whatever the units are supposed to be, so that whoever's looking at it knows what we're trying to say. For my students doing this, what I recommended was that you do, since this is lesson 16 and 17, that you start by doing 16A, and then do 17A, then do 16B, then 17B, and keep going. And that you maybe don't need to do, I'm not necessarily asking you to do 2 full lessons, but to do about half of each lesson, and until you get the hang of what we're doing. So, but that's for my students. If your math teacher asks you to do something different, you should do what they ask you to do. So thanks so much for watching. I hope you have enjoyed this video, and I'll see you in the next one. Thanks.